Hi everyone, I am Rebecca from PFE Medical, and firstly I'd like to thank DAS for inviting us today to speak about the importance of validating UVC cabinets when we are disinfecting semi-critical devices such as ultrasound probes and ENT scopes. We were the first company to introduce this technology to the UK 14 years ago with Germitex AS1 and A1 system. God, wait there guys. Just give me a sec. They've now evolved into the Kronos and the Kronos Max. So we've been doing this since 2012 and got over 300 machines installed nationwide. As the suppliers of high-level disinfection systems, we've always believed that validation should be carried out to the highest possible standard, even in the absence of formal guidance, and that's been our approach for the last 14 years. As NHS Wales was one of the first early adopters of this technology, we felt it was important to invite John Prendergast to present. I'm sure most of you already know John, but John is a principal decontamination engineer within the specialist team at NHS Wales. He's also an AED with the responsibility of all aspects of decontamination and reprocessing techniques for medical devices. If you'd like more information about the Kronos and the Kronos Max, we're just at the stand on the right as soon as you come out the room. And I'll now pass you over to John.
I think Rebecca's right. I think we had an incident in Wales, 2011, 2012, with a TOE probe, a cardiac probe, and it did concentrate us to look at our systems. We had Welsh government-sponsored surveys to investigate, well, what's going on there. You know, let's go and have a look and let's see what the situation is. And Rebecca's right. We looked at UV as an option because things like ultrasound probes, ENT, you know, it's not quite as easy to formulate a correct decontamination protocol. How many of you have had the old discussion, you know, is the risks are no greater than a knife and fork for ENT scopes? I think Helen rightly contradicted that earlier this morning. So, yeah, let's have a look at UV turning light into a line of defence. Disclaimer again, yeah, I'm very Teflon. Again, this is nothing to do with my NHS employment, and I'm here as an independent AED. Much as it's great to be working with Rebecca and the team, I'm not linked to PFE. You know, I work across a number of suppliers of such technology. So often we're misled, aren't we? UV sterilisation. Well, it's not sterilisation, it's disinfection at best. Yeah? It's got to be kept in the correct context. Now, when we look at UV disinfection, it's been around many applications for many, many years. Water services, environmental surfaces, air quality, and then we come on to medical devices, yeah? So it's something that probably was looked at probably many years after the initial rollout. UV inactivates microorganisms by damaging the DNA and RNA of the organisms themselves, yeah? And that will hopefully prevent replication, which gives us the outcome we require. As we said, there is no one size fits all with decontamination. We would like everything to go back to an accredited sterile service department for terminal sterilisation, but the reality is that's not going to happen. Like I said, many ultrasound applications, the decontamination needs to be done at point of use. The devices can be disengaged. However, the more you do that, you damage the pins, you end up having to buy new equipment at vast expense. So in the applications of ENT, TOEs, ultrasound, etc., there is scope to use this type of technology. However, it's got to be done in the right and appropriate manner. So this is not me talking, this is the industry talking. There's been a number of historical concerns, and I think, you know, the likes of PFE, they've had to answer many of these concerns over many, many years. Limited penetration, yeah? The ability to deactivate organic material. The ability to get in the crevices and the nooks and crannies of the devices. Shadowing has been an obvious outcome, and I think we've all been on the beach with our hat on, and we find we've got a big red face, but the top of our head is untouched. Yeah, that's probably a good example of shadowing. There's an argument, and I'm not here to discuss this because I'm not a microbiologist, but there's an argument that it's less effective against some pathogens, yeah? Biofilm and some spores in particular have been highlighted within research. Material degradation, yeah? Compatibility. Now, how many of you remember the medical device alert in regard controlled environment storage cabinets, the old AFOS cabinet, yeah? But I'd like to look at that sensibly, because that was an endoscope sitting in a cabinet with a UV light, potentially for 31 days. That exposure is significant. The applications we are talking about, the exposure may be 2-3 minutes. Yeah. So albeit we're never going to get away from the degradation debate and discussion, and it should be treated in the right context. It is not sterilisation, and there are safety risks if the equipment is not performing as it should. So it's a balance of risk, isn't it? And we need to always come back to balance of risk. And what we found with the Welsh Government surveys, it was like the Wild West out there, yeah? The further away you go from accredited departments, you will be surprised what you see. So on the back of that, we developed WHTM 0106 Part F, something you haven't got in England, I may add. Yeah? It is open to purchase. I will be outside with a hat later, £100 a time, and you can have a copy. So, when you look in Part F, it says, high-level disinfection using manual multi-wipe systems is the least preferred option for disinfecting ultrasound probes. Now, I'm not here arguing to say that multi-wipe systems are not effective. Indeed, they probably are. The problem is the human being, yeah? And the inconsistency will always be there with a human being. So that does present a challenge. When we use systems like I'm showing there, ignore the green example of a cleaning solution there, but that is what happens with those type of things. Somebody comes along, leaves the lid open, and the outcome is a wipe that is drier than my pizza last night. And that was mighty dry, I may add. I had to have 2 pints of lager to swill it down. I didn't intend to drink, Sam, you know me. So, when we're using system A, C or D, pre-cleaning is highly essential. We can't get away from that, yeah? And that is part of the process. And compatibility is a key part again, yeah? We have to investigate these compatibility statements. Now, in Part F, we are dedicating a couple of paragraphs to the various systems that we have available, UV being one. Yeah? And again, we say that if we do use UV technology, robust validation is critical. Yeah? So it's not just a matter of putting it in. The supplier says it's effective against A, B, and C. We're now happy to go. It has to be validated accordingly. And again, we always go back, compatibility. Yeah? Those are the key fundamentals if we are choosing to use such systems. We have to make sure we have the direct exposure. And the exposure dose is essential, yeah? That exposure dose will be set up during type testing, and so we has touched upon the importance of type testing a little bit earlier. That dose must be consistent, so the time must be consistent, the frequency of that dose must be consistent as well. The position of the UV source, the distance from the lamps is highly important as well, yeah? And that must hold that device in the same position on each occasion, yeah? If the bracket starts to wear and it's half an inch lower, you need to let the manufacturer know. Indemnity, something we've been very keen on with suppliers of this type of technology. We need to have an indemnity statement from them to say that if there is any unforeseen damage to a device, they will investigate, and if they are deemed responsible, they will provide compensation. Now, thankfully, we've had a few brushes with that indemnity agreement, but there's not been any major action to be taken on that. But there has been one or two, and when you come to probe damage, whether it be with hydrogen peroxide, UV, it always becomes a bit of a misty debate. So we have to get things correct when we're doing that. So how do we validate? And again, I think the team previous touched on this. There is no definitive standard at this stage for medical device decontamination systems. It is not new technology. I think Rebecca highlighted it's been around between 12 and 15 years. There's a variability in the use of process challenges and surrogates used for the validation, something we need to be a little bit more robust on. Standard chemical indicators, yeah? How do we know each cycle has the correct exposure? So this is something that we need to investigate. And is our microbiological challenge applicable, yeah? If we think of a transvaginal probe, the microorganisms there are going to be different to an ENT device, yeah? So we need to consult with our microbiology teams on that. So validation requirements, type testing, we highlighted earlier. But type testing is a grey area, because you ask manufacturers, can I see your type testing information? How many actually come forward with that information? Yeah? They will claim as commercially sensitive, and I probably agree with that. However, in the event of a debate on the effectiveness of a process, you need to have that information. Then we have the standard validation requirements: installation qualification, operational qualification, and performance qualification. We have periodic validation, and we have cycle verification. So when we look at type testing, the suppliers must have the evidence behind it to say that, you know, given the correct dose delivery with the correct distance from the holding mechanism, that it does present the correct microbiological inactivation. Yeah, I think everybody would agree with that. It has to be safe for staff, patients, yeah? So that needs to be covered with the type test information. Material durability. We're coming back to common themes here, yeah? If we have UV exposure on scope A supplied by Olympus, and I'm not picking on Olympus, but lo and behold, they're in the back of the room, yeah? There has to be compliance to a plethora of manufacturing standards. And there has to be a declaration of conformity to all those particular standards. Now, the type testing, in the event of an argument between a supplier and a trust, that information should be presented to back up the information provided, yeah? So the procurement department should build something in a statement in the procurement documents to state that fact. Then we have the installation qualification, typically done in what they call commissioning, carried out by the supplier, the manufacturer. So this will confirm the electrical integrity of the system. It will confirm the safe positioning. So if you look at that, that particular machine is taller than me. So it's got to be in a safe place, securely bracketed, etc. Those are the things that we cover during the IQ process. Interlock safety, yeah, we've talked about UV being a harm to staff. We don't want that door suddenly becoming open during a cycle. So we need to make sure that. We need to make sure the loading systems are robust. It recognises when a device is inserted and it recognises when the device has been removed. And it has to have the correct alarm operations for that particular design, because each design will have a little bit of a variability. Operational qualification. Again, we're repeating the safety checks. This is a typical format for any sort of decontamination equipment. We do the ACT, the automatic control test. We do a verification of calibration on the control systems. Yeah, if it's set at a control temperature, we need to make sure that control temperature is correct. Again, critical alarm tests. So if a lamp fails, it should pick that up. It must, we must provide evidence of dose intensity and dose mapping. Yeah, so we need to be sure that everywhere in that chamber is exposed to the dose. And if there's any air circulation systems in there, it needs to confirm that that circulation is as per the type test information. Performance qualification, these are microbiological tests. Yeah? Now they should be undertaken by a UCAS accredited laboratory, not by some laboratory that may be the other side of the garage. Yeah? It's got to be done correctly. Now I spoke to a couple of microbiologists on this, talking about our standard microbiological tests, and they seemed happy that Pseudomonas aeruginosa and Staph aureus seem to be a relative microorganism to test these machines. So I'm sure there are others, you know, and that would be down to your microbiologists. They may share a different view to the people I've discussed this with. So when we look at worst case testing and in other areas of sterilisation and decontamination, we go through what they call half cycle lethality, where we actually half the exposure. So as an example, it could be a 10-minute hold time on an ethylene oxide sterilisation process. They half it to 5 minutes. That is something that we may need to look at with this type of technology. We either half the amount of dose, so we disengage a number of the lamps, or again, we half the exposure time. Something that needs to be looked at, I think, as part of the validation. So to use real-life simulation, we will be using inoculated carriers. Yeah? So the carriers will be inoculated with a volume of microorganisms, and then we will actually test at the end of that process. The inoculated carriers must be as per the type testing. So it all goes back to that type test data. That's why it's important that we, as AEDs and clients, have access to that particular information. So when we look at individual cycle verification, there has to be parametric release, there has to be a printout. Now, all too often, equipment such as this comes along and they say, well, where's the information? It's on a memory stick. How can we release the load if we don't see that information? Yeah? We need to have skilled operators reviewing that cycle information. They may not understand the total technical aspects of that, and it's not that in depth, but they should be trained to a standard to release the load on that. Also, we should have typical UV exposure strips, yeah? That prevents inadvertent release of an unvalidated load. Something that we're having issues with other areas at the moment. Frequency of validation. So some manufacturers will come in and say, once a year validation is fine. You've got to be hellishly confident in your system to go once a year, yeah? A lot can go wrong in that period. So we need to determine frequency of validations, and I think there should be a modicum of validation at quarterly intervals. If we think of these devices, yeah, we talk about semi-critical, critical as per Spalding. Now the critical medical devices go through steam sterilisation with a log reduction off the scale. It's got proper thermal disinfection, proper cleaning through a validated washer disinfectors. Some of these systems are nowhere near that. So what is the true critical and what is the true semi-critical? I'll leave that with you. I'm not arguing that point here today. So we need to identify the risk and we validate accordingly. If you think we talk about that point of use ultrasound, yeah, this is coming our way if it's not here already. Look at that, that's a mobile phone. That could be used by a midwife in a domestic dwelling. Are they going to be carrying one of Rebecca's UV disinfection systems to a house? Yeah? I doubt it. There's a manual handling issue there, isn't there? So that's the next challenge. I know we migrate a little bit. So, to summarise, if we use these devices in the right context, UV of non-lumined medical devices can be achieved. Yeah? So concerns in some ways are unfounded, but we have got to make sure we take on the right context. Pre-cleaning and rinsing. Yeah, it's not just about putting some fairy liquid on it and just giving it an old wipe. We have to rinse the residues off there before it goes into the UV machine. That is where the compatibility issues and probe damage actually originates from, residues interacting with the UV. Compatibility must be confirmed, or at least indemnity agreements put in place. Validation must be robust, yeah? It's not just having a plug-and-play unit. You have to do that validation as part of the commissioning and periodic validation to support. So, I think the development of a standard is essential, and I believe, Brian, we had a conversation last week, I believe it is in development. So watch this space. We may have that standard 12 months, Brian? Possibly longer. Okay, so just watch this space. I think there will be, manufacturing standards that are applicable, and it will help our situation.